let's solve this system using matrices. The system is negative x plus 3y equals 5 and 3x minus 9y equals negative 15. So our initial matrix will look like negative 1, 3, 5, 3, negative 9, negative 15. And this is nice because it's easy to get a positive 1 in the first position by multiplying everything in row 1 by negative 1. Our new system will be, let's see, positive 1, negative 3, negative 5, and we didn't change row 2, it is still 3, negative 9, negative 15. So we achieved the first goal, which was to make d11 equal to 1. The second goal is to make d21, the element right below the one we just got, equal to 0. Well, since it is currently 3, and 3 plus 3 plus negative 3 equals 0, we're going to use the command negative 3 times row 1 plus row 2 will give us a new row 2. So let's see. Sorry about that, everything fell. Okay, let's see where we are. Alrighty, so let's see. Row 1 is currently 1, negative 3, negative 5. If we multiply that row by negative 3, we get negative 3, positive 9, positive 15. Now let's write down row 2. Row 2 is currently positive 3, negative 9, negative 15. When we add the second and third rows, let's say 3 minus 3 is 0. This is the new row 2. 9 minus 9 is 0. 15 minus 15 is 0. Goodness, we've got zeros all the way across in row 2. So our resulting matrix looks like 1, negative 3, negative 5, 0, 0, 0. There's several things to notice about this second row. When we have all zeros in a row, remember our next goal is usually to make d22 equal to 1. But we've got a 0. I can multiply 0 by anything in the world and I'll still get 0 as an answer. There's no way to get 1. So it is impossible. Let's write that down. To get a 1 in D1, in D22. That leads us to write down the equation that is represented currently by row 2. So let's see, we've got 0 times x plus 0 times y equals 0. On the left side here, 0 times anything is 0, and 0 plus 0 is 0. And do you see that without any x or y, this thing is still always true? That means that there are infinitely many solutions. But they're not just any numbers in the whole world. The solutions are made up of these two lines. And this is how we're going to work it. Whenever you have a statement that is always true, that row, and it's in row 2 this time, that row is kind of flexible. So we are going to let y, the second variable, be just some t, where t can be any number. T can be 5 or 3 or negative 11, it doesn't matter. T can be anything. And then we're going to write the equation from the first row. Let's see. So we've got 1 times x minus 3 times y equals negative 5. We want to let y equal t, like we decided just a moment ago, and solve for x. Okay, so we've got a couple of steps here. Let's see, we've got x minus 3, instead of y we want t, equals negative 5. To get x alone, we can add 3t to both sides. That'll give us x equals 3t minus 5. That means that our solution looks like 3t minus 5 comma t where t is any number. And that seems weird, totally very weird. So let's look at something. Let's look at our original equations. Our original system was, let's see, negative x plus 3y equals 5, and 3x minus 9y equals negative 15. And let's check that bizarre looking solution we just found. Let's see, what did it look like? 3t minus 5, comma t, where t is any number. Okay, so in line 1, negative x plus 3y equals 5. For x, I'm going to put 3t minus 5, so negative 3t minus 5 plus, and for y, I'm just going to put t. Let's see what we get. Negative times 3t is negative 3t. Negative times negative 5 is positive 5. And we have plus 3t. Negative 3t plus 3t is 0, so on the left we only have 5, and that matches. Very bizarre. Now let's look at equation 2. 3x minus 9y equals negative 15. 3 times 3t minus 5 minus 9 times t, and that should be negative 15. 3 times 3t is 9t. 3 times negative 5 is negative 15, and we have a minus 9t here. 9t minus 9t goes away. We're just left with negative 15 on the left, which matches the right. So in a weird way, this solution matches or satisfies both of these original equations. But let's see what it really looks like. Let's see where that comes from. So let's take, it doesn't matter which one we choose. I'm going to choose the first one. Let's see, so I've got negative x plus 3y equals 5. We usually, when we're graphing lines, we usually solve for y and get x on the other side. Let's solve for x. Let's get y on the other side. So we've got negative x. I'm going to subtract 3y from both sides to move the y to the right. So negative x is equal to negative 3y plus 5. And then to get positive x, I'm going to multiply everything by negative 1. On the left, I've got x. On the right, negative 3y times negative 1 is positive 3y. Positive 5 times negative 1 is negative 5. And do you see this is exactly what we have? 3t minus 5, 3y minus 5, but we let the y be represented by t. So what this means is our original system had one line. Both equations were the same line. That means that this system it has a solution, so it's consistent, but it doesn't have one solution, it has infinitely many, so it is dependent.